Hello everyone. Thank you for joining this live session. So, to be fully honest, this is a post-made video. Why am I doing a post-made video? Because the first time I created it, there were blank spaces on my live. Unfortunately, I didn't know they were there, so I decided to redo and make it better for my audience. So today I'll be taking you through subnetting made simple, and yeah, that's what we're going to do today. Um, so a bit about me. My name is Ivan. I am a lover of cloud, and that's why I want to make it simple for you today. And yeah, we will interact more as we go along. So starting us off is a bit of history on how subnetting came along. So before the 1990s, IP addresses were divided into classes. So there was class A, class B, and class C. So the problem here was that we could see that there was a waste in addresses. So for example, you could see that a small businesses with limited number of computers would be assigned a public IP that had close to 65,000 IPs, whereas it needed probably 1,000 or less IPs. So this would leave most IPs unused, making it quite, how can I put this word, quite extravagant, yeah, to say the least. So as the internet continued to grow, we we meaning the older people in my generation, no, in our generation, so that these IPs were getting used up, and decided to come up with what we call now CIDR, or you can put it as classless interdomain routing. So the aim of this was to solve uh, the problem of wastages and the quickly depleting numbers of IPs. So they produced flexible addresses instead of fixed classes like the A, B, and C. So here you could see someone using an IP address of class A in in a class C setup. So I think to understand more about this, you'll be required to go into deep networking classes. But for our session, we'll limit ourselves to a few terminologies about subnetting and how we can use it in our simple beginner guide in AWS. So uh, what we could see here now was that you could use a class A network to offer a class C, uh, a class C subnet, and it became useful. So here we see that we are using private addresses, and then if you want to go public, probably your company will be required to have a public IP that is connected to your private, and then traffic will be routed through the through the ports and go to the specific destination that you want it to. So with that short history, I think we can continue and see what I have for you today. Yeah. So yeah, we have a few definitions and terms. So we can go to uh, what is subnetting. So ideally, subnetting is dividing a large network into small parts. So for our case, we can look at it. Um, we can look at it from the point of the network being a large city, and then subdividing it into neighborhoods. So which example can I use? that everyone will relate to. Mm, mm, You can think, okay, let's say, let's look at food. And if you're hungry, go get something. Imagine you have a big slice of pizza. So you want to subdivide it, the pieces that you want. So the first piece, the whole pizza is what we call your large network, and you can now subdivide it into small networks. You'll get to see it and to understand it more as we go along. So the second definition we see here is VPC. So a VPC is is your isolated network in the cloud. So for this, uh, you can look at the VPC in terms of the cloud as your own section in the internet, where have you have taken it to be yours. So to put it clearer in your mind, um, you can look at it from a perspective of a world city. Like what? The Great Wall of China. I think that is what everyone can relate to. I think if it surrounds China, I don't know if it surrounds China, but if it does, uh, if it does surround China, you can look at it from that perspective, that it's a section they enclosed for themselves. Yeah. So we can see the classless interdomain routing, or what we now call CIDR. Um, hmm. So it's a system for allocating IP addresses, IP address block efficiently. So what do we mean by this? So let's say, for example, your organization what? Has 200 PCs, and you have a block. You have taken a block of, say, a slash 16. So you can divide that entire block into a range of IP addresses that fit the 200 devices in your network. So how you do this is by creating subnets, small subnets into the bigger block. But you'll get also to see this as we go along. So we got the CIDR notation. So what does this CIDR notation mean? So the CIDR notation can start from a /8, /16, /24, or it basically starts from there, but it can vary. So we can get a /25, 26, 27, 28, /17, 18, 19. Because I think it's divided into two parts. So we have the network portion and the host portion. So they are divided into two parts. So when you divide them into two, the CIDR notation comes in to represent the network portion of your network. So for example, you have a /24. What does this mean? It means that your network portion has 24 bits, and then it has a remaining 8 bits for your host. So you'll get to understand this more through an example. I think it's easier to learn through examples. So usable IPs is the number of IPs that you can allocate to your devices, and we'll also get to see that. Yeah. So moving on swiftly, we move to our first stop, which is what is our VPC. So ideally, our VPC is an isolated place or environment in our network, which is quite interesting. Um, uh, it's where you can host your AWS services. Yeah. So today we are going to demystify subnetting by comparing it to planning a city. Looks interesting, right? Yeah. By the end, you'll be able to see how a virtual or VPC, our virtual private cloud works like a city, and subnets acts like neighborhoods, and our CIDR for planning and organizing. So, um, mhm. So we can see that our VPC is the entire city. So we can look at it as our private and secure space in the AWS region. Um, so what we do now is like try to allocate postal addresses to our neighborhoods in a way. So that is where CIDR comes in. So uh, in this neighborhood, you might find that your house is number one. You have your neighbor who's number two. You have another neighbor who's number three. So you individually know where your neighbor lives. So if you want to send a message, you can send it to door number three. Door number three will reply it to door number one. And if door number two wants to join into the chat, it will be also added. So you can look at CIDR as the 1, 2, 3 that you've added onto your houses so that they can be located clearly in your neighborhood and the city at large. So in our case, we can look at our neighborhoods as subnets. So you have neighborhood A that contains people and houses who are 50 kilometers away from guys in neighborhood B who have, say, 300 houses or so. So in neighborhood A, you have guys with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 addresses. That's what we call CIDR. And in a neighborhood B, which is our subnet B, we have guys who are 1, 2, 3, 4, 5, 6, 7, 8 as addresses. I hope that makes sense. Yeah. Quite interesting. So, just a moment. So, I think from our previous definition, we can get to clearly understand what a VPC is. So we deploy services like our EC2 in this VPC. We can deploy services like our databases in this VPC, and we can give them addresses. But before we give them addresses, we have to think of the number of resources we are putting in our AWS environment, because we do not want to be wasteful. We want to be mindful of how we're using these things, how we are allocating our IPs and making it efficient, and also trying to curb the areas that would cause an error in our network. Yeah, quite interesting concepts. Yeah. So in our subnets, we see subnets as our neighborhoods. Yeah, just like I have stated earlier. So in our case, if we were using or we were doing this practically, probably we would have a public and private subnet. But I guess we'll get to see this as we progress. Yeah. So probably what we would want is to host our database in our private subnet and host our what we call our front-facing server on the public subnet. So ideally, how this would work on a real on real life would be probably what you see in your e-commerce sites, where you get a front-facing site where you can order and purchase stuff. And what you do not get to see is how the database works. It just works magically. That's the beauty of the internet. Yeah. So yeah, just like we said earlier, CIDR is like the addresses your in your neighborhood A, the 1, 2, 3, 4, 5, 6, and in your neighborhood B, 1, 2, 3, 4, 5, 6. So here we see that we're using a pizza analogy. So let's use the pizza. So A/16 CIDR is the whole pizza, which has over 65k IPs. That is 65,000 IPs. So A/24 is a slice with 256 IPs, and AWS reserves a total of 5 IPs per subnet for routing and DNS. So the usable IPs is equal to IPs minus 5. So in our case, a /24 will be equal to 256 IPs. Minus the 5, you get 251 usable IPs. So if your organization has 240 devices, you can just allocate the 251, and that will be efficient enough. Yeah, I think it will be efficient enough. Yeah. So if your organization has less devices, let's say it's a small office network, you'll need less IPs. So ideally, you you'll use the /28 to get your 11 usable IPs. So it's quite interesting. Yeah. So here you can see how subnetting works. So before getting into these details, I want you to picture the entire block of IPs, the entire block of your entire block that is in the VPC as 10 as a /16. So the entire block has the ability to create subnets within the entire block of a /16 block. So how I would want you to picture this is your VPC has a block of, let's say, 10.10.10/16, which is 65,000 IPs, and then you'll be able to create subnets in it. So you have subnet A as what? You have subnet A as your neighborhood that requires IPs, and subnet B that is in your neighborhood that requires IP. So ideally, you have to think on how you'll be able to give your IPs and see the need of each neighborhood. So if you have like 300 houses in subnet B, you'll be able to know the number of IP addresses you require for them, and let's say 100 houses in subnet A, you'll be able to know the number of IPs you require. So here we get starting with a CIDR block of 10.0.0.0/16, which gives us 65,536 IPs. So this is our city, aka our virtual private cloud. Yes. So we want to subdivide this into subnets. So for our public subnet, we will have a 10.0.1.0/24 address for 256 IP addresses. So if we subtract the 5, we get 251 usable IP addresses. So the /24 will be for our public subnet, or A, our subnet A, or our neighborhood A. We can also subdivide it into a private subnet where we get a 10.0.2.0/28, where we get 16 IPs, but now we have 11 usable IP addresses. So we can get to see, okay, if someone would come and ask you where you got the /24 and /28 from, why you're using 10.0.0.1 on public subnet 1 or public subnet 2. And you'll get to understand this as we move along, I'm sure. So just hold on, just hold on. I won't lose you. And if I do, you can always ask a question on the chat and I'll be able to respond. Please feel free to respond, to ask your questions. I will respond. So here we can see how to calculate. So the formula is your total IPs. So your total IPs is equal. Okay, I think I should have made this better, but let's see. You have your total IPs is equals to 2 into bracket 32 minus the CIDR number. So why are we saying 32? So if in your IP address you can change this into the entire IP address, let's say the 10.0.0.0 into what we call them, you can convert them into binary, sorry. So when you convert them into binary, just a minute. So ideally what this would be, sorry, I had to find a way on how to edit this so you can be able to see better. So let's just go back a little bit onto our slide. See if it's this one. No, I think it's this one. Yeah. So ideally, let's see. So to make you understand better, in our address we have 10.0.0.0/16. So if we convert this into its subnet mask, we get it as 255.255.255.0. So ideally, if we represent this into binary format, what we have is the 255.255.255.0. What ideally we have is 1. That's how many ones? 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4. Oh, sorry, I made a mistake there. So this should be dot O. I'm thinking of class C networks. So I think we should do this. Remove this. Put this here. The O. 1, 2, 3, 4. 1, 2, 3, 4. Dot 1, 2, 3, 4. 1, 2, 3, 4. So ideally, what this is, so where we get the /16 and /24 part. So our host bit is this from this part, from this section here, up to here, and our network bit is from this section up to here. So the /16 comes in by taking the first 8 bits and the second 8 bits, making a total of 16 bits. So this will be our network portion, and the host portion is now this. So for our /24 here now, if we convert this into our subnet mask, we get 255.255.255.255.0, which in turn gives us a binary format of 111.123.4.123.4.5678 dot 1. Is this going to fit? Is this going to fit really? Let me see. Yeah. 1234567 dot 1234567. So where the 256 IPs come in is in this section here, the host bit. So that's how we get the /24 /20. So let's suppose it's a /25. You want to a /28. What you do, you add the existing the number, the bits that you have added. So if it was a /24 and you want a /28, so this is 24, 25, 26, 27, 28. So you get, so our network address starts from here up to around here. Cool, right? Yes, I know. So we get our host portion as this section here, which has 4 bits. Yeah. So moving from this, I think we can go to this slide and discuss now how we get to 256. So let's see if I can edit this a little bit before we continue. So our total IPs would be 2 raised. So this should be, I'm sorry for doing this now. I thought it would be easier. Okay, where's this thing? It's not here. Let's see if I can get it here. Yeah, I got it somewhere. Let's see if I can paste it here. Yeah. So it should be 2 raised to 32 minus the CIDR number. So in our example, where are we getting 32? So as we can see, the bits here, the 8 bits. So this is the first 8, second 8, third 8, the fourth 8 bits. They add up to a total of 32. So coming back here, we can subtract. So 32 minus our 24, we get 28. So 28 raised to 28. So we get 2 raised to the power of 28, which we get 256 IPs. But let's make sure this is true. So let me open. You can also open up your calculator to confirm. Calculator. That is calendar. Sorry, just a moment. Sometimes math can be hard. So if I open up my calculator to confirm, get 2 raised to the power of 28 That's a lot of IPs. Shouldn't be this. Yeah, I think we made a mistake somewhere. So ideally it's not 28. So 32, 32 minus 24. Yeah, 32 minus 24 should be around 8. So 2 raised to the power of 8 is what we call 256. So we are on the right track. The mathematics was a bit challenging, but we're there. So moving on swiftly, before I lose you, we can see that we got our 256 IPs. So what AWS does, it reserves the 5 IPs, and now you get 251 IP addresses to use for your network. Yeah. Yeah. So this is what I was coming to. It's already here. So just a minute, let it load. And we're back. So what does the /24 mean and the /28 mean? So the network bits is the 24 bits of the 32-bit IPv4 address. So the 8 bits remaining are the host bits. So if we do this should be 2 raised, just a moment, I think this needs to be corrected first. If you do 2 raised to the power of 2 raised to the power of 8 is what we get. 256 is how we get 256. Yeah, I think we need to prepare better. Yeah, so in our case, as what we have started and done, is we got the 256 addresses here, and then so what do we mean by standard calculation? So if you are doing this outside AWS, not in the AWS environment, let's say in your environment, you would subtract 2 addresses, the network address and your broadcast address. So the network address is, I think, the first address you get for your subnet, and now you get the first usable address. And then when you come to the last bit, you get the last usable address, and then now you get the broadcast address. It's structured that way just for clarity and usage. But now when you get into the AWS environments, you get from your CIDR block and your subnet. AWS takes 5 addresses, and you get to subtract this from them and move forward. So yeah, I think it's been beautiful. So I think the common issues faced in this network is ideally the one that I've come across is on how can I put it, clashing IP addresses. I think there's a word for it. Let's see. There should be a word. Yeah, it's overlapping addresses. So ideally, what this is, it means that, let's say you have, let me see if I can edit here. We have it already. So so imagine you have your PC as a /16 10.0/16 address, and in this 10.0/16 address you subnet. Okay, you create your subnets or neighborhood A as /10.0.0/28, and your neighborhood B, has a 10.0.0.0/24. So you can see that there might be some conflicts there, because in a /24 network, a /24 network is ideally bigger than a /28. So what happens is that /20, the IP addresses in a /28 network also live in a /24 network. So ideally, if they are communicating with each other, which I assume that would be your purpose, that would be your intent on creating these two subnets to communicate with each other, there will be a conflict of addresses. You see? So how we mitigate this is by offering a different network address to your subnet. So for instance, let me do it here so you can be able to understand. So for instance, how do I do this? So for instance, this is our CIDR block 10.0.0.0/16 is our CIDR block, or what we call our VPC. It's the entire VPC, yeah? So subnet A is 10/0/0/0/24 or 25, whichever you choose, is subnet A, and 10.0.0.0/28 is subnet B. So what happens is that the IP addresses here in the /24 network contain all the IP addresses in a /28 network, because we see the same way the /16 network holds all the IP addresses here is the same way the /24 has an equivalent number of similar number, the same number of IPs as /28 network. So ideally, this is what we call overlapping, because if subnet A has an address like, and this is an example, it might not be what's on the ground, 10/0/5 in subnet A. In subnet B we have, let's say subnet A has, let's say 150, and this has 10.0.150. So these two IP addresses conflict. Why? Because this address is here and this address is here. So we have, yes, they knock head. They knock head. Yeah, I think that's what my Nigerian friends would say. They knock head. So so ideally it's similar to this. So the IP ranges from, so this is an entirely different example. So imagine your VPC is a big plot of land with a CIDR block of /16, and subnet A is a /24 with IP ranging from 10.0.1.0 to 10.0.1.255. And you have your subnet B as 10.0.1.128/25 with IP ranges from 10.0.1.128 to 10.0.1.125. So as you can see, subnet A and subnet B have conflicting number of IPs. So here we get the description of where the problem starts. So in subnet A, we have these ranges of IPs. Subnet B, we have this range of IPs. So the conflict actually begins from the first usable address to the last usable address in subnet B. So you see, you just gotta think a little bit, and you get where you're going. So the issue is the overlapping issue in AWS. Mm, issue will face is that your subnet will fail to deploy, and it will pop up. It will give you a red error that is scary, and you do not want to face that. So you get another routing chaos, which is I don't know if it happens. I believe that if you have an overlapping subnet, you won't be able to create a subnet. But I think I will need to research more on this and give you feedback. Uh, yeah, and you also have security risks. Let's say if you have something in your private subnet that has a similar IP address with what's on your public facing side, I think you might have a challenge. People might access your resources that are on a private subnet and cause harm, ideally. Yeah. Mm, these other small issues, I think uh, it's if you just didn't plan yourself properly. But so let's say, for example, you need 300 IPs and you allocate 200 IPs, you get a smaller number of IP addresses. Yeah. So forgetting availability zones. It's a plan. These are planning issues. I think if you just plan yourself correctly on how you're going to implement your subnetting strategies, how you're going to implement your subnet, you'll be okay. You'll be okay. So I'd like you to post any questions you have about this topic on the comment section below. And okay, I think that this is where I say follow for more. Yes, follow for more. But before I end this, I'd like to share a slide presentation of how we're going to put in our subnets in the virtual network. But okay, I'd like to share this in terms of Nextwork. So I'll show you the project on Nextwork, and then from there, I'd encourage you to do it, because ideally it's something that exposes you and makes you more knowledgeable on matters AWS. So let me share my screen, and then we can continue. So this is interesting. This the screen appears to be black. I hope you can see. I really do hope you can see. So in this project, we get to create a private subnet. So in this private subnet, we get to see a couple of steps. We can set up. So actually, this is just those are two train of thoughts coming and going. So in this is a Nextwork project that teaches you on how to create private subnets, how to deploy them in the cloud, how to build your VPC. It's quite an interesting project. I believe that this can be quite beneficial to you. You can do it. You can make it your go-to project when you want to learn about subnets and the cloud. So ideally, the Nextwork platform offers a variety of projects that you can do in AWS, and I'd encourage you to go and see them, check them out, and enjoy them. So here we were creating the private subnet. I'm sorry. I don't know. Something is happening. I don't know what's happening. But yes, we will look at it and make it better. So we were doing this. We were hosting our public subnet security group, our EC2 instance. This is our resource. Yeah, so it was an interesting project, but so I believe this was the previous project. Now this is what we were doing, an explanation of what we were doing. So ideally, you would create the public and private subnet and connect the public to the internet, assign IPs in the public subnet and the private subnet, and see how your VPC looks like. You get to create your VPC. You get to create your VPC. I think the steps are clearly outlined. So here you create your VPC, you set up your private subnet, you set your route table, your knuckles, and then you're all done. It's nice work. You're all done. Quite interesting. And you get to see, or you get to do it with Natasha. Natasha is one of the next top guys, quite lovely, and I believe she will guide you properly on this project. And if you feel like you want to get readsy and you want to read through, can do it using the low touch or the high touch version and get to do the project. And never forget to delete your resources. Yeah, so feel free to comment if you get stuck. Feel free to throw a thumbs up. Feel free to like and share. I never thought those words would come into my mouth. Gosh, it'll come out of my mouth. Why yo? But no, it's too hard. We are together. We are together. So that's it from me today. I hope to see you soon, and cheers.